Hello everyone, today me and my group is here to present on the topic of secure network design and implementation, and the group members are me myself Ayush Shakya, Amrit Neupane, Ayush Lal Shrestha, Ayush Shah and Barshana Shrestha. So talking about our project, we're working as a network engineer for a fast growing company in Australia. The company has two branches in Perth and in Queensland, and we're required to establish a secure VPN network in between the branches. Will also require for remote users who will be traveling across both the branches, and they will require connections uh, at the same time. So talking about scopes and limitations of project, the two branches will be linked together with the help of three routers. The main network in Adelaide will have an IP address of 10.1.1.1 on the Perth side, whereas 20.1.1.1 on the Queensland side. The Perth network will have an IP address of 192.168.1.1 and a subnetwork of 24, whereas Queensland network will have an IP address of 192.168 2.1 in a subnetwork of 24. Talking about the requirements of devices, the device requirements are pretty much the same for both the branches. Will be requiring switches, routers, computers, and servers, along with a wireless device. Routers will be using Cisco 1941 router. Will require two devices for both the branches. Switch will be using Cisco 2960 iOS 15. Will require 3 units for each branch. Computers we choose for Dell Optiplex 3050, whereas server is Lenovo ThinkServer. So for the next slide, I want to pass it over to my friend. Thank
Hi everyone, I'm Barshana Shrestha and I'll be talking about the logical design. So this is the logical design of the network. Here we have used Draw.io as a network drawing tool to form this design. In this diagram, we can see that there are three routers. The main router is in Adelaide office and it relates to two other routers that are in the branch offices, Perth and Queensland respectively. The diagram basically shows the logical view of the branch offices, and the diagram depicts the VPN tunneling between the routers and indicates the IP addresses of both networks, which forms the entire network. Now, talking about the physical design, logical design has been used as a reference to construct this design. It shows the actual components that we have used in the logical network. Through the diagram, we can see that there are two branch offices, Perth and Queensland, that are linked to each other via three routers. The main network in Adelaide will have an IP address of 10.1.1 on the Perth side and 20.1.1.1 on the Queensland side. Perth network will have an IP address of 192.168.1.1, while the Queensland side will have an IP address of 192.168.2.1. The branch router is connected with a server, and the server switch, which is then connected to the client switches, and those switches are connected to multiple devices. Those devices should be able to access the network. The ultimate goal of the design is to show the VPN tunneling between the branch routers that basically secures the data when transporting between those two branches through a public network. Now I'll be passing it to my friend. Thank you.
Hey guys, so moving on to network and topology for our project. So we've got basically three networks connected to each other, the two branch network and one main network, and it is basically based on a star topology, which consists of a central node like hub or switch, and the data, everything passing from one side to another has to pass through the central hub. And the basic reasons for choosing star topology is because it is very commonly used LAN topology in various organizations, and the isolation of failed devices is possible. In case something fails down, the whole network does not have to go down, and it is very easy to install and troubleshoot, and the network can be expanded if required. So moving on to the disadvantages, the only thing that's considered disadvantage is since everything has to go to the central node, it might be a victim of single point failure, and more cable length is required for star topologies. That's why it might be a little bit expensive. And talking about topology, you can see we've got two networks on right hand side and left hand side each, and the middle one is Adelaide. That's the main network. So moving on to IP addressing, IP version 4 addressing scheme is utilized over here in our network, and we have utilized both the class C private and public IP addresses. You can see 10.000 network, that is private IP is utilized within the internal network between the routers, and whereas on the end user sides, two public IP addresses are utilized, and static IPs are provided to the machines in this scenario. And moving on to IP tables, we've got a bunch of tables over here that outlines the devices and the interface along with the IP addresses that are provided in our case. So we've got PCs, servers, switches, and routers, and the respective IP addresses and respective port number or interface number over here. For next slide, I'd like to pass it to my friend.
Talking about the security policies and features, the security of the network necessitates the enforcement. This may be accomplished in several ways. For example, the network can be fitted with a firewall and allows the user to access either the entire network or a specific selection of it. However, there is another approach to maintaining network security. For the approach setting of security association and cryptographic keys, our network architecture employed as ISAMP, which is also known as Internet Security Association and Key Management Protocol, defined by RFC 2408. We've also implemented security protocols like IPsec and agreements like ISAMKP. Some of the phases are listed below. Organization may grow, necessitate more resources. So as a result, the following network should be designed to assist the additional software and asset security policies. Talking about the recovery plan, in the event of data being breached, the primary servers must back up all the files and data to prevent the loss of vital documents, and file adding business continuity plans to secure the business continuously. The network is given network IP address, which will ensure the firm grow. The IP address will be able to accommodate the additional loss services.
I'll be describing the all the configuration in this topology. So basically what we did was create a VPN tunnel between the Perth and the Queensland side. So we have three sites: Adelaide, which is a main branch, and we have configured the 10 network for the Adelaide, and also applied the routing protocol, RIP routing protocol, in all of these router so that they can communicate with each other. So let's see if we can ping port side to Adelaide or not. So it is successful. That means we have configured correctly. And let's see what we did in configuration of for creating a VPN tunnel. So CLI, yeah, we have to apply certain crypto ISAKMP policies in this, and let's see what we have applied. We have applied policy number 10, and so running configuration. Okay, we have applied crypto ISAKMP policy number 10. And for the encryption, we have applied 256 SAR to 56, and authentication pre-share, we have enabled this one. We have set the lifetime for 3600, which is probably 1 hour. And crypto ISAKMP key, this key should be the same in both of the sites. Otherwise, you cannot create a VPN tunneling, or the data packets will not be secure or encrypted. So you need to set the peer to which you are going to send the data or packets. Let's see more what we have did. Yep, we are configured the IP address and routing protocol, which is RIP. And let's see if we can ping from the Perth side to the Queensland side. Showing in progress, failed, always fail for the first time. So let's try it again. Progress, fail. Okay, now it's successful. So yeah, the VPN tunneling was successful, and let's see if the data packets are encrypted or not. Okay, so for that you need to type so crypto IPsec so IPsec Security Association, and okay, it gives you all the details of the VPN tunneling. So current peer is 20.1.1.2, which is this Queensland site, and port number is 500, through which the data packets are sent. And while sending the data packets, it encapsulated 2 data packets, encrypted 2 data packets here. So this means the VPN tunneling was successful, and we, as per the assignment requirement, we have also added some of the remote user here so that they can connect to either sides through the VPN tunneling. For now it takes time because I have just opened up the file, and we have the servers in each side, and different departments. They all can communicate with each other, because we already have created a VPN tunneling and we have applied their routing protocols. So that's all the topology configuration we have made, and thank you.